Haumea, the strangest dwarf planet of all. This is one of the strangest objects in the solar system. It's classified as a dwarf planet, but it's not round. It has a ring of asteroids like Saturn's, but not as visible. Despite being very small, it has 2 moons. It has a flattened shape that gives it the appearance of an egg and spins faster than any other object in the solar system. This is Haumea, the strangest dwarf planet of all. Would you like to know why astronomers are so intrigued by this object? Let's find out. Haumea is a dwarf planet that lies in the Kuiper belt, a region of icy donut-shaped bodies beyond the orbit of Neptune, much like the asteroid belt between Mars and Jupiter, but farther from the Sun. For that reason, all objects in that place are icy and often covered in ice. Objects like Haumea that lie beyond the orbit of Neptune are classified as trans-Neptunian objects. These are very difficult to study due to their small size, low brightness, and enormous distances that separate us from them. The image we show at the beginning of the video is only an artistic representation of Haumea. Today we have not yet managed to photograph this object in a high resolution because no probe has ever been sent to explore it closely, just like it was done with Pluto. In 2003, the New Horizons probe managed to photograph the dwarf planet Pluto, showing white and dark colors with a surface covered with impact craters. Haumea has characteristics very similar to Pluto. Both are at similar distances from the Sun, and studies indicate that they are composed of very similar materials. With all that information, the artistic images we currently have of Haumea have been elaborated, but in practice, even with our most powerful telescopes, Haumea is seen as a point of light orbited by 2 other more minor points. With a radius of about 385 miles or 620 kilometers, Haumea is about 1/114th the radius of Earth. In addition, it is 43 astronomical units from the Sun. From this distance, it takes 6 hours for sunlight traveling from the Sun to Haumea. Measurements of its orbital velocity indicate that Haumea takes 285 Earth years to go around the Sun. However, it has an eccentric period. In its journey around the Sun, it moves far away and then gets very close. At its closest point, it approaches the Sun more than Pluto. An irregular shape. Haumea is a curious object. It revolves around the Sun in an elliptical orbit that takes 284 years to complete. It is currently about 50 times the distance between the Earth and the Sun from us, and its rotation speed is 3.9 hours, much faster than any other body over 100 kilometers in the entire solar system. When observed through a telescope, it looks like a point of light moving through the entire background of stars. However, it shows large fluctuations in brightness over 3.9 hours. One of the explanations for this phenomenon is that there was some other body orbiting around it that hid its light from us, just like exoplanets do when they block the light from their star as it passes right in front of us. However, after many analyses of Haumea's brightness dips, scientists concluded that the dip in brightness could not be due to another object orbiting around it, but rather to the object having a rotation period lasting precisely 3.9 hours. This is faster than any known equilibrium body in the solar system and, in fact, faster than any other known body over 100 kilometers in diameter. While most rotating bodies in equilibrium flatten into oblate spheroids, Haumea rotates so rapidly that it is distorted into a triaxial ellipsoid. If Haumea spun much faster, it would be distorted into a dumbbell shape and split into 2 objects. It is believed that this rapid rotation was caused by the impact that created its satellites. Images captured with telescopes indicate that Haumea is as bright as snow. 80% of Haumea's surface appears to be pure crystalline ice, with a contributor to the high albedo that could be oxygen cyanide or phyllosilicatic clays. Inorganic cyanide salts such as potassium or copper cyanide may also be present. In 2005, the Gemini and Keck telescopes could independently obtain Haumea's light spectrum, which shows large numbers of ice crystals similar to that seen on the surface of Pluto's moon Charon. Further studies of the visible and near-infrared spectra suggest a homogeneous surface covered by a 1-to-1 mixture of amorphous and crystalline ice and 8% organic compounds. This is unusual for an object, as crystalline ice forms at more than 100 to 110 K. However, the surface temperature of Haumea is less than 50 K, which is thermodynamically more favorable for amorphous ice formation. Then for crystalline ice to form, there must have been an increase in temperature, either by collisions that heated the surface layers or by the heat emanating from the interior of the planetoid. Moons on a dwarf planet. Dwarf planets are characterized by being smaller than the Moon, the natural satellite of the Earth. However, despite being so small, some of them have moons, although much smaller than that of the Earth. This is interesting, considering that Mercury and Venus have no natural satellites, despite being bigger than Haumea and other dwarf planets. Would you like us to make a video explaining why Mercury and Venus don't have moons like Earth? Let us know with your valuable comment. On January 6, 2005, the W.M. Keck Observatory discovered a natural satellite orbiting Haumea. An interesting fact is that initially the team of astronomer Michael Brown, who had been involved in the discovery of Haumea, called the planetoid Santa because they discovered it on December 28th. For that reason, the satellite discovered in 2005 was given the provisional name of Rudolph, an allusion to the central reindeer of Santa Claus. The satellite was later named 136108 Haumea, Hiaka. It is the outermost, most significant and brightest satellite of Haumea, about 310 kilometers in diameter. It orbits in a nearly circular trajectory with a translation period of 49 days at a distance of 50,000 kilometers. Its absorption characteristics in the infrared spectrum are consistent with its surface being covered mainly with almost pure crystalline ice. The satellite's unusual light spectrum plus absorption lines similar to those of Haumea led a Caltech team to conclude that the moons must be fragments of the dwarf planet itself, so that they would have arisen from a collision millions of years ago. Later in the same year, on June 30th, a new satellite was discovered and given the provisional name of Blitzen, later renamed 136108 Haumea 2 Namaka. It is the most miniature satellite and closest to Haumea. It has a highly elliptical orbit, which travels in 18 days, and according to measurements made in 2008, it tilts 13 degrees concerning the plane of the orbit of the largest satellite, which disturbs its own. The relatively large eccentricities and mutual inclination of satellite orbits are unexpected, as tidal effects should have dampened them. Isn't alone. Haumea is the most prominent member of the collisional family that bears its name. A collisional family is a group of astronomical objects with similar physical and orbital characteristics that could have had a common origin. There are several theories about the origin of this collisional family. Astronomer Michael Brown, a pioneer in discovering dwarf planets, proposed that it is formed due to the direct impact that tore away the Haumea ice sheet. Another hypothesis, based on a high-speed collision, suggests that the material ejected in the initial collision merged into a large Haumea moon, which was later destroyed in a second collision, scattering its fragments outward. However, the Kuiper belt is very unpopulated, so the chance of a collision in the ancient solar system is less than 0.1%. The Haumea collisional family could not have formed in the primordial, denser Kuiper belt because such a tight-knit group would have been altered by Neptune's migration within the belt, which is thought to be the cause of the low current density of the Kuiper belt. Therefore, it is suggested that the origin of the object that collided with Haumea and its relatives lie in the dynamic region of the scattered disk, in which the possibility of such a collision is much higher. A dwarf planet with rings. Although Saturn is the planet with the largest and most colorful asteroid rings, in reality, Jupiter, Uranus, and Neptune also have asteroid rings. The difference is that these are only visible with infrared cameras, since their rings are very faint in visible light. One of the most exciting and unexpected finds on the dwarf planet Haumea is discovering a ring of asteroids around it. Until just a few years ago, we only knew about the existence of rings around giant planets. Recently discovered that two small bodies between Jupiter and Neptune, belonging to the family of objects called centaurs, have rings. Now have discovered that bodies even farther away than centaurs, more extensive and with very different characteristics, can also have rings. The first of them to be discovered is Haumea. According to the data obtained from the occultation, The ring is in the equatorial plane of the dwarf planet. It shows a 3-to-1 resonance concerning the rotation of Haumea, which means that the icy particles that make up the ring complete a spin around the planet in the time in which it rotates 3 times on itself. There are several possible explanations for the formation of Haumea's asteroid ring. For example, it could have originated after a collision with another object, or by releasing some of the surface material due to the rapid rotation of Haumea. This is the first finding of a ring around a trans-Neptunian object, and shows that the presence of rings could be much more common than previously believed, both in our solar system and other planetary systems. Thanks to all this information, we know that Haumea is one of the strangest objects in the solar system. Even temperature analysis on its surface indicates that the speed of rotation of the planetoid could generate large amounts of friction inside, which would eventually produce heat, and this would melt the ice, turning it into water. Is it possible that there is water in Haumea? Most scientists think not, since it is too far from the Sun. However, many astronomers do not rule out the possibility. Do you think there is water in Haumea? Let us know your opinion in the comments.